All right, so we take a look at this question. Integrating, what we see here, of course, is the telltale square roots of x squared plus a squared. So if we go back to our chart, you're going to see that we're going to want to substitute in x equals a tan theta. Okay, so over here off to the side, we're going to go x equals a tan theta. And what's the a going to be? Well, again, the a is the square root of the constant. So x equals 2 tan theta. We are going to want to, next thing that you should probably always do is find dx, because we're right there. You're going to have to get dx in terms of theta as well, because we're already started to put this function in terms of theta. So that's the first sort of substitution with the trig that we're doing. So let's do dx. The derivative of tan is secant squared theta, d theta, right? Derivative of tan, secant squared theta d theta. Now, what about this outside of the root sign here? Do we have an issue here with x squared? Well, we did a question like this yesterday, I think, right, when we had x squared out here. And it's no problem, because we have x. Here is x right here, 2 tan theta. So we'll just square it and put it out there as well. So we rewrite this integral now as 1 over, I'm just going to go ahead and write 4 tan squared theta, just to eliminate some work later on, because that's what the x squared actually is. And this is the square root of, so x is 2 tan theta, so let's just go 4 tan squared theta plus 4. And then our d theta, we need this in d theta, so dx is 2 secant squared theta d theta. Okay? And that right there is the first major, that's the biggest, well, probably the biggest part of the question is substituting those trig functions in. So you're going to see here in this very next step that we're going to get rid of this root sign, and everything's going to collapse a little bit, and it's going to be a little bit simpler to look at. So what do we got here? What do we need to rewrite here? Can we just simplify this out of the air here, maybe just mentally? So we take a 4 out, we're going to have root 4 of tan squared theta plus 1. What did we say tan squared theta plus 1 was again? Anybody remember that? It's secant squared theta. So secant squared theta equals 1 plus tan squared theta. So if we have square root of 4 times 1 plus tan squared theta, or tan squared theta plus 1, we actually have the square root of 4 secant squared theta. So this is going to be now 4 tan squared theta times this right here actually simplifies to 2 secant theta. Does that make sense? That's going to be 2 secant theta.
Can you cancel out the 2 secant?
Yeah.
Secant squared theta?
Yeah. We're gonna get there. We can. You're absolutely right. We can do some canceling here now. So we have. Make sure we got this going on here. So we've got a. Okay. All right. So is everybody good there? So the 2. Yeah. So this 2 can cancel out with this 2. This secant can cancel out with this secant. All right. So we're going to have the number out front, the coefficient out front. We can just put that out front here. It's going to be 1/4. What's that going to be? Secant theta over tan squared theta, d theta. And then if we just kind of do our work with it, we can write secant and tan squared in terms of sine and cos and see what we got. So secant is 1 over cosine. So that would be like cosine down here at the bottom. Tan squared is sine squared over cos squared. So that's like cos squared over sine squared. So this goes with this. And we have cos theta over sine squared theta. And when you have this part, now we have a function and its derivative in this all wrapped up together. So this is a candidate for u substitution. Yeah, so now we can do u sub. So this is kind of like the example where we went from x to theta to u, did our integrating at that point, And then we went back to resubstitute back to theta, back to x for our answer. So that's where we're at. So I'll just change pens here. So u is going to be what? What do you think u should be? Yeah, if you see this cos theta d theta here, if u was sine theta, then du is going to be cos theta d theta. All right. So then we have, over here, we have 1/4 still, the integral of 1 over u squared, and then of course this is just du now. Right? Because that's what du is. All right, so now we're at a point where this is really easy to integrate. So again, the strength of trig substitution is going from this nastiness over here, right? Doing a couple rounds of substitution to get to this right here, which is totally doable. Okay, so that's going to be, that's u to the negative 2. So let's do 1/4 times, so we have u to the negative 2, we add 1, so that's going to be u to the negative 1, and we're going to divide by that, so that's 1 over negative 1, and then plus c. Okay, so that's going to be, negative 1 over u. So I'm just going to, so that's going to be 1/4 times negative 1 over u. So we could do negative 1/4 with a u on the bottom there, plus c. So that's the integrated portion. Now we're going to resubstitute back in. So u is, we said u is sine theta. So we have negative 1/4, and if you want to do this separately, times 1 over sine theta, that's fine. Okay, plus c. But we don't want in terms of sine theta either, so we have to go back and figure out how theta and x are related. So we go back here and we notice that way back here, we set x equal to tan theta. Or, so x equals 2 tan theta from before. So tan theta equals x over 2. And this is where we go to our right triangles now. So we have a right triangle. This is going to be theta. We know that tan is, that's TOA, right, in the SOHCAHTOA, opposite over adjacent. So this is going to be x over 2 like that. Okay? And this side here, the hypotenuse, is going to be the square root of this side squared plus this side squared. 4 plus x squared. And usually that's sort of where we start with, right? So that's kind of nice. Usually that's something that we start with when we get to that spot. So it all kind of comes full circle. So now I can figure out sine, cos, whatever, secant, cotan, whatever you want here from this right triangle. This is the relationship now. And so sine is going to be opposite over hypotenuse. So sine theta is x over root 4 plus x squared. So our answer, I'll put this in red here now, is going to be negative 1/4 times x over root 4 plus x squared, all plus c or plus k, whatever you're using nowadays. And then just maybe clean that up a bit. X over 4, root 4 plus x squared, plus c. And make sure I got that a negative there. Don't forget that negative. That's like that. Yeah. Okay. Wait a minute. Wait just 1 minute. This is the reciprocal. So my bad here. Sorry, a little distracted there. So this is going to be the reciprocal of that. So everything's got to get flipped. I think I did that last time, didn't I? With an example. So 1 over sine theta. It's not 1 times sine theta. It's 1 over sine theta. So yeah. So final answer is going to be. Give me some red still. So we've got to flip that. So that's going to be root 4 plus x squared on top over 4x and a negative. That looks better. Plus c. All right. So, got that? Any questions about that? So when you've got this pattern, root x squared plus 4, that you go back to your chart there, where did we do this? Way back here. Kidding. Did a lot of work yesterday. So when you see one of these right here, then you know what to substitute. And of course, this was this tan. Doesn't matter if it's x squared plus a squared or a squared plus x squared. Still use your tan there. And then so you want to put that in terms of theta, which will get rid of a radical, is the intention. And then you might have to do some u substitution. Thank you. And resubstitute back. Got it? Okay. So there are different variations of questions. I'm going to give you an assignment now where you can work on some different questions.